introduce the next speaker, which is Simone Mangiante from Vodafone UK, that will give us a telecom perspective of fog.
Hello, everybody. Thank you, Antonio, for inviting Vodafone to this workshop about edge computing. My name is Simone Mangiante. I'm in the R&D group in Vodafone in UK, and I'm here on behalf of my manager, Gunther Klaas, who is pretty known in this topic. And I will give you a talk about the edge computing in the perspective of a service provider, network operator. So I'll go a little bit about what it is, edge computing, use cases and drivers, very short overview of some business motivation, and then challenges and conclusion about this topic. So to start, I think all of you are aware of the edge cloud computing, so no need to explain what it is and why we are talking about it today. Some interesting remarks are the role of operator in this, and this is the bottom right. So the operator, what does the operator want out of the edge? So they want to provide edge cloud computing infrastructure, hosting own software and third-party software for third-party developers and services, and they want to provide value-added services from their network, enabling new services and new improvements on their services, and also have some profit on that. So this is a comparison about what is the edge and where is the edge. It's one of the issues that we are facing now. On the right, Amazon edges are more or less geographically distributed, based, I think, on users' density. And on the left, there is a sketch of a network operator network, internal network. So edge computing nodes can be placed near the small cells in Cloud Run, in the core. So there are multiple places, many options on where to put these edge nodes. And the motivation is quite aligned between network operators and cloud providers, or top tiers, over-the-top providers. So lower latency, I will talk about it a bit later. It's one of the main motivation for the edge, higher throughput as well, but also quality of experience, and for us, new 5G services. So next week in Barcelona there is Mobile World Congress, so we'll know new 5G use cases. So this is the buzzword that will be moving along the edge topic. In terms of architecture, I have a nice slide about architectures that have been proposed and have been implemented so far. So here is the actual situation, like the traditional two tiers: devices and central cloud. Everything goes to the center and back. It's happening today. It works. Some IoT use cases started to put gateways on premise near the enterprise, and it's also happening today. And there are many use cases of that. Another style is CDN, content delivery networks. So CDN, like caching nodes, for example, Amazon and Google, they put micro data centers. It's closer to the cloud than to the user. And also there are a combination of these two. So IoT applications that benefit both from IoT gateways and micro data center nodes, caching nodes, for example, or analytics nodes. What we are, as a network operator company, studying now, it's putting mobile edge computing and edge nodes in the axis, so in the middle between the user and the central cloud. And it's a work, for example, being developed and being standardized by ETSI, MEC, and we are part of ETSI, MEC, of course, and it's demanded for new 5G applications. And the final message here is that edge nodes can be in many places, and probably must be and will be in many places depending on the application that we want to deploy and we want to make benefits for that. So there is not a single point of deployment for edge nodes, but they probably will coexist in different, in this the cloud, it's things to cloud continuum that we saw before. And in this slide, I made a more detailed picture of where in the future we can put some edge nodes. So on the right side, you have all the companies, use cases, applications that want to leverage from the cloud some distributed computation, distributed capabilities, and on the left you see again the network diagram, a little bit more detailed, and we can put the edge almost anywhere on the device, on the small cells, on the core network, on enterprises at the bottom with some very special radio, wireless, ultra low latency connectivity, for example. So this is again a problem that we need to solve and that we are facing. About main drivers, I listed some of the trends that have become important in the edge computing, so CDN, IoT, NFV, enterprise, standardization, fog computing, cloudlets, so all these 5G at the bottom, all of these trends compete probably to define what the edge computing will be. And we see a lot of use cases. This is just an example. On the left again, we have main drivers, mostly from the 5G, so industry 4.0, IoT, and then connected cars, wearables, all these low latency 5G use cases. And on the right, video analytics, gaming. Gaming is important, both cloud gaming and serious gaming, cloud robotics, VR. So there are a lot of startup, a lot of buzzwords, a lot of new services that we see, and that they probably need some enhancement from edge nodes, from edge computing. But we don't really know how to achieve that, because software functions can be replaced again almost anywhere, from the devices to the cloud. So like in this software defined world now, all these functions like face recognition, classifiers, for example, or analytics, they can be on the device, they can be near to the user, they can be on the core, and measuring the efficiency of these different places is hard, and it's hard to decide what is the best place to deploy and maintain these functions, these software functions. And from the network perspective, it's even harder because you need to take into account also internal network function, internal network services, that they are becoming softwareized as well towards this NFV, SDN revolution, if you want. So in this simplified view of the network, again, you need to make red network functions and blue third-party functions, cloud functions, coexist in the same network. And there are many options to make that, because you can have already existing resources deployed on some nodes, and you want to leverage that. You don't want to build new nodes. You want to deploy and manage and maintain new resources only because of blue applications, but you want to share red and blue stuff. Latency is one of the main drivers for the edge computing, and we had a lot of conversation with academic and other vendors and many trials, many proof of concept, and latency requirements vary according to use cases. So you might want very low latency like 5G goal, 5G target like 1 millisecond for connected cars, car avoidance, assisted robotic. You might want 10 milliseconds. 10 milliseconds could be enough for other application, but also 50 milliseconds. Why not? You can play games with 50 milliseconds, and for other use cases, you can be happy with 100 milliseconds. So latency vary, and this latency is application latency, not network latency. So for us, it's more difficult because all the numbers that we saw before are application, a latency that take into account also processing, delay processing, and the budget for the network, it's smaller. So when you strip off all the computation delay, computation processing, your budget, the network delay budget, is even less than the number that we saw before. So again, you need to think where to put the right functions in the right place. And we had some study with Carnegie Mellon, and here is an example of face recognition application with many deployments, many scenarios, and the best is the black one, the black line, when there is a cloudlet near the device. And even if you don't offload anything, it's the pinkish line on the device itself. The latency is worse. And then when the farther you move from Pittsburgh, where they had their testbed, to the Far East, the latency becomes worse. With, for example, the red one in Amazon EC2 in Asia, in the Asia region. And we are active on this topic. We are part member of 2 proof of concepts in the ETSI MEC standardization, one on video analytics and one on IoT industry 4.0 use case. And then we have internal trials, internal proof of concept on automotive, offload, traffic offload for YouTube, edge platform for IoT, and some work on 360 video and VR streaming. And as I said before, we have partnership with Carnegie Mellon universities, and we are member of this open edge computing that was born after the first initial Cloudlet work from them. A little bit about business. So here we have an example of the business implication of the edge computing. So there are cloud providers that want to extend their application, they want to distribute their application more. Enterprises want new services, want to reduce costs. Network operators like Vodafone want to expand their business and create new services. And also vendors, they want to be part of this. They want to be part of that. They want to sell nodes, sell hardware and software to implement that. And for telecom network is a matter of, again, adding new services and save money, but also adding new services and hosting new capabilities, and attract also developers and new businesses in this edge computing area. The revenue opportunities are, again, anywhere in the network, because according to your deployment, you can leverage offering and different offering and different services, and you can make benefit out of that. So it's a pretty complex scenario, and you want to maximize your income and, of course, minimize the deployment effort, minimize the management effort for these nodes, and maybe also try to offload as much as possible to cloud operators or vendors, maybe just rent the connectivity. So the business model, as we saw before, it's not very clear even for the infrastructure level of edge computing. This is technology overview of the edge computing efforts so far. So we have fog computing, we have Cloudlets, we have MEC, we have micro data centers. So we have many players in this landscape, and we want to have a unified view of this edge computing scenario, because we want to harmonize everything, and we want help from this organization and this initiative to solve challenges that we see in the edge computing, because some use cases are not very clear and probably not very now clear for the main investors and the main business people to go into the edge computing. So we need some very clear motivation to continue the work on this. Application developers, we need to engage application developers a lot, and we need to make them aware that we have a new way of deploying application and writing application and services. For that, we need some API, standard APIs. And again, all these consortia here, they need to agree on something unified and uniform for network APIs exposure. And we need to integrate with existing architecture, existing SDN, NFV, OSS pieces that are already in place. So we don't want to reinvent the same thing and waste resources and waste money and time to deploy something new, but we want to leverage what's already there. And another important thing is to speak with the cloud service providers and try to find a nice collaboration with big cloud providers like Google, Amazon, Facebook, and decide some integration between them and the cloud, how they can efficiently deploy applications and services using clouds in the telecom networks. These are the questions that we have in our group every day, and then we have on our own, and we also hear from our stakeholders and our managers. This is more, this lies more on generic question, like how do we integrate this edge computing to other initiative, NFV and OSS initiative, and architecture and deployment that we are already seeing in many telecom networks. Legal requirements, security and privacy requirements, very important. Security often comes later in this kind of new issues, new paradigm. It's better to think about security and privacy from the beginning and not just add it later in some weird way on top of that. To do that, we need to test existing use cases, new use cases. We need to gather all the players. In some places, like open labs, open test beds, and check interoperability and check the feasibility of this deployment and this architecture. And we also need to be on the edge of the technology because network operators, they are always some years behind. So for example, the MEC standardization is focused around VM. What happens with new way like containers in terms of the concepts, not just the technology. So what will change, what would change? And at the bottom, again, top cloud providers, they need new workload mechanism to be able to use this edge cloud. We see some work like Amazon Lambda or Amazon Greengrass, for example, but we need synergy with them, so we don't want to do the same thing in two different ways. We should harmonize the work with them. Okay, it's hard because everyone has its own business, but it's something ideally to be targeted for the next years. And in terms of architecture and technology, these are main questions on the deployment of the technology. So robustness, reliability, resilience, scaling, sizing, how this edge node should be packaged, should be deployed, should be orchestrated, and by whom? Network operators, application developers, cloud providers, what's the best approach to integrate all of these things. It's something, again, not yet defined, probably not even yet discussed in the same room, but it's something to be aware of. And OpenStack is the future, is the only opportunity. We need to converge on some platform with modification for enabling this edge computing, or there will be other more efficient way to do it. We don't know. And also other kind of problems like VM migration with non-disruptive switch from one edge to another. So again, there are a lot of studies for Carnegie Mellon, for example, on VM migration there and containers. So These are again another old architecture and technology related open issues and questions that we want to address. In conclusion, we see that the edge computing is somehow interesting, it's successful, and it's reasonably good for some use cases and can be enabled by telecom service providers. So there is scope for network operators to be part of the cake here, and we need more engagement again from developers, application developers. We need standardized APIs and agreement on APIs, more experiments, more tests, because we need to solve technical challenges and business challenges. And to do that, we need some collaboration. And today was important to be here and hear about open fog computing, because we think that initiatives like open fog can help in all of these points here. For example, integration with the cloud in this continuum between thing and cloud, strategies, best practices for deployment and scalability of these nodes, maybe new use cases, new trials, new tests, and new possibilities to talk with cloud providers or vendors, and best practices, recommendation on security and privacy, multi-tenancy, so how to orchestrate and how to deploy this edge node to be not a single domain for Amazon or for Google, but to share the infrastructure for many use cases and try to make it more efficient and more scalable, and group together all these standard bodies like IIC, ETSI, Open Edge Computing in the same place. I think that's it. It was fast. Do you have questions?
We have time for questions.
Hi, nice talk. I really appreciated the focus on many of the things you presented, actually. To me, it seems that among the challenges you proposed, it's clear, at least from your proposal, that we need to address a kind of paradigm shift, calling for new ways to define application, and also to deploy them in this quite complex scenario. Then you were clearly stating, I totally agree with you, on the keenness of these aspects, on the requirement from tenants regarding legal aspects, quality of services, and also, on the other hand, from the user, the end user that is using actually the services, to preserve his quality of experience. Well, to me, at least from my perspective, this means a call for a new way to represent the service level agreement in this complex scenario that is somehow different from the traditional way in which we are used to express them, these kind of items. Usually, you have to interface with a cloud or at most with many clouds within a federation. Here, it's far more complex also because we have different kind of interests that are, one is from the telecom company, the one from user, and the one from the cloud provider. How do you see this from the perspective of your presentation?
It's a hard question. I mean, we need to define some standardized, maybe APIs or standardized approaches to make this work, make this feasible in all the domains, because we have these cloud providers, they have to be aware of nodes, like edge nodes in the telecom network, so there must be a mechanisms to discover and to make the application work on the network itself. I don't know if there will be agreement, one-to-one agreement between network operators and cloud operators to host their nodes, to host their applications close to the network operators' nodes, or maybe it will be completely open, an open APIs to be used by anyone, any third-party software. I don't know. It's the open API, the openness. It's not very real, probably. For especially if you look at the past tentatives, past attempts from the network operators, so they don't tend to be very open. So maybe there will be a one-to-one agreement with cloud operators, and we also see that cloud operators are trying to overcome deploying edge nodes at the internet exchanges, edge nodes into other places. So there is we are going from two points, trying to converge on the same one from two different directions. And the customers want some improvements. They want enterprise want guaranteed services. So again, we'll need to define probably new SLAs, take into account this edge distribution, and because enterprises will pay for this distribution of loads, and they want that to be on their constraint. So it's a very complex scenario that we are opening here, and discussions will last, I think, years. There's no answer yet. I hope that all the standard bodies and all the groups will help the landscape. We have to define a shape, a stable shape, at least.
More questions? One is just a curiosity. If from the viewpoint of those that play, let's say, the role of telecom providers, do you foresee some kind of killing application that can be judged as something that makes all these factors, let's say, to run together to concretize a little bit the work that has been done on the area?
Killing applications, there is not yet like a single one killing application that you want to bet on. There are many applications, many proof of concepts, like connected cars. Automotive is a big driver and will be also in the future. So there is a lot of attention on that, a lot of attraction on that, and because it's a mix of low latency, cloud distribution, security, privacy, legal requirements. So it makes everything together. It puts everything together in the same use case. Other applications are related to videos, like all these new VR service, VR experiments, again, with mobile users, not only fixed access. So this, again, it demands a lot of work on the latency part, but also, again, on the privacy part. So video and cars are the main two application that we are looking at. And then for the customers, and then for more enterprise market, IoT, industrial IoT, and robotics, and automation of enterprises.
So let's thank the speaker again.